the enemy is given, and so the enemy is given a ciphertext. A ciphertext, so that's a ciphertext. For example, I call it A star B star, which is actually equal to GK star and YK star times M star. I denoted a star, that means that is what we are looking for. Okay, so the enemy is given A star B star, and the enemy is, the purpose of the enemy is, the task of the enemy is to find X star given the decryption oracle. So what it means is, the enemy needs to find M star. The enemy needs to find the message M star, but the enemy is given an access to the decryption oracle. Remember what's the decryption oracle? There's a program in which the enemy can give any ciphertext except the ciphertext in question. Okay, so what happens is, I can show like this. There is a decryption program. You can give ciphertext, you will get M. The decryption program has a key U. You can give any ciphertext as long as the ciphertext is not A star B star. Okay, now I want to show you that in this situation, actually ElGamal is not secure. ElGamal is not secure against chosen ciphertext attack. What does it mean? It means that if I give this decryption to the enemy, then ElGamal can be attacked by the enemy. That means the enemy can output M star. So how can the enemy output M star? The enemy will do like this. So the enemy will do the following. Right, remember the question is A star B star. You cannot give A star B star to the decryption program. Okay? So what the enemy will do is, the enemy will try, just select a random number R, which is between 0 and P minus 1. Any random number. And then the enemy will compute P hat is equal to R times P star modulo P. Okay? And then the enemy will provide A star, P hat to the decryption program. The decryption oracle. Then finally, the enemy will retrieve M star from S3 divided by R. Okay, so this is the step that the enemy will do. So this one is actually a little bit hard to understand, right? So just try to follow my explanation. So the first step is I choose a random number, okay, R. And then the second one, so I will rewrite it here. The second step is basically we compute B bar is R times B star modulo P. What is this one? This is equal to R times P star. You see, P star is a question here. Okay, it's a question here. So that means it's equal to Y K star times M star. That is actually the so-called P star. Okay, everyone follow? That's the so-called P star. So now, after we know what P star is, then we provide A star, P bar to decryption oracle D. You can see that A star and B bar is different from the question that is asked. The question that is asked is A star, B star. This one is A star, B bar. That means the decryption oracle will decrypt this. Do you understand? Okay? Decryption oracle will decrypt this. Okay, so what is A star, B bar? So I will rewrite here. A star is G to the K star. as per the question. Of course, we do not know what K star is. P bar, we know P bar is here. R, Y, K star, M star. Of course, we do not know K star and we do not know M bar, M star. Okay? The question now is, I give this one to the decryption oracle. The decryption oracle will decrypt this for me. Okay? So you can see that what the decryption oracle will do, the decryption oracle actually will decrypt this. That means the decryption oracle will decrypt, if you remember the formula, is B bar divided by A star to the power of U. Okay? So remember, this is the decryption. There is nothing new, everything is here. B divided by A to the U. And then, but here, the question is B bar divided by A star to the U. Okay? So what is this? So this one is I call M bar. What is this one? This is actually, if you look carefully, this is actually equal to R times Y K star M star divided by G K star to the power of U. Okay? Alright? So you can see that now I will swap this R. This is Y K star. This is M star divided by G to the U to the power of K star. Yes? Right? So you can see that G to the U, what is G to the U? G to the U is from the public key. At the top, we have G to the U is equal to Y. Okay? So that means this is actually equal to Y. Y to the power of K star. Okay? So that means I can cross this one and that one. Right? So I can cross this one. And that's why the result is actually equal to R M star modulo P. So that's why you can see in step 4, we need to retrieve M star by doing M bar divided by R modulo P. How can we divide by R? Because if you remember, R is selected by the enemy. So the enemy knows the value R. Okay? So now you can get, this is R times M star divided by R. So in this case, you get M star modulo P, which is the output that the enemy needs to generate M star. Okay, so you can see that from this proof, this is to show that ElGamal is insecure against chosen ciphertext effect. Okay, so that is actually the proof. So in the example, if I ask you, this is an easy question, will we show that ElGamal is insecure against chosen ciphertext effect? That should be like this. Okay, if I ask you, is RSA secure against chosen ciphertext effect? Then you need to think. Yes? Alright, you need to think. How? Is it secure or not? So you need to think like this. But if I ask you, is ElGamal secure or not? That's easy. You just need to do like this. Here the answer is not secure. But that's the reason. Yeah. Okay. This one is a little bit hard to understand, but if you follow my explanation, you should be able to understand. Right? You should be able to understand. This is just normal mathematics. There's